Okay, so welcome to the Level 2 Video 1. We are going to be talking about solving quadratic equations by factoring. And factoring is something that we've done before, only with polynomial expressions. So it's the same thing as doing polynomial expressions. We're going to use the box method, we're going to use the X method, we're also going to use GCF in some of these instances, but let's get started. So, number one, we have a quadratic trinomial, and the coefficient of m squared is 1. So you should remember from the last standard that we're going to use the box method here. So what we do is we split up our m evenly. I need two numbers when multiplied together equal a -14, but when added together equal a -5. That's going to be a -7 and a 2. And then we're going to write our binomials. We're also going to write the equals 0 to part. We can't forget about that. And then we're going to go one step further here. Now, by the zero products property, which is what we learned in level 1, we can find what m equals. So I'm going to take my one factor, which is m minus 7, and set it equal to 0. And solve for m by adding 7 to both sides. So one of my answers is m is equal to 7. And then I'm going to take my other factor, which is an m plus a 2, and I'm going to set that equal to 0. And subtracting 2 from both sides, I get m could also be a -2, and that would make this equation true. So this has two solutions here. M could be equal to a -2. M could also be equal to a 7 to make this equation true. And if you wanted to check your answers, you can always put -2 or 7 back into your original problem to see if you come up with a true statement. Number 2, again we have a quadratic trinomial with a coefficient of my first term being 1. So this is another box method problem. We take our p squared, we split it up evenly. I need two numbers when multiplied together equal -20, but when added together equal +1. That's going to be a +5 and a -4. And so now I'm going to write my binomials as a p plus a 5 times a p minus a 4, and we can't forget the equals 0. And now by the zero products property, I can set both of these binomials equal to 0. So I'm going to set a p plus a 5 equal to 0, and I'm going to subtract 5 from both sides to get p is equal to a -5. And then I'm also going to set the p minus 4 equal to 0. And I'm going to solve for p by adding 4 to both sides, and I get p could also be a value of 4. So this one also has two real number solutions. One of my solutions is -5. My other is 4. All right, looking at number 3. This time we have a quadratic trinomial, but my coefficient of a squared is greater than 1. So in this situation, we are going to use the X method, which I'm going to review with you right now. So in the X method, in the top of your X, you do your a times your c value. So that would be a 2a squared times an 18. So that's a 36a squared that goes in the top of your X. In the bottom of your X is your b value, which in this case is a -15a. I need two numbers when multiplied together equal 36a squared, but when added together equal -15a. That is going to be a -3a and a -12a. All right, so now I rewrite my quadratic equation as a 2a squared minus a 3a minus a 12a plus an 18 is equal to 0. Now that we have 4 terms, we're going to use factoring by grouping. My greatest common factor out of my first two terms would be an a, and I'm left with a 2a minus a 3. Out of my next two terms, I would factor out a -6, and I'd be left with a 2a minus a 3. Now, one of my binomials is going to be the stuff on the outside of parentheses. You know you did this correctly if your parentheses match, and one of your other binomials would just be one set of those parentheses. All right, now by the zero products property, I'm going to take my a minus 6 and set that equal to 0 and solve for a by adding 6 to both sides. And I get a could be 6. But I'm also going to take my 2a minus 3 and set that equal to 0 and solve for a here by adding 3 to both sides to have a 2a is equal to a 3 and dividing by 2 on both sides to get a is equal to a 3/2. So you get two real answers for here as well. A could be 6, but a could also be 3/2. All right, looking at number 4, the method of factoring only works when we have our equation set equal to 0. Like in 1, 2, and 3, we already had it set equal to 0. So in 4, 5, and 6, we do not have our equation set equal to 0, but we can get them set equal to 0. For example, in number 4, I can add 49 over to the other side of my equation, and I'd be left with an x squared plus a 14x plus a 49 is equal to a negative 49 plus a 49 is a 0. And now I have something like I did in number 1. I'm going to use the box method on this because it's a quadratic trinomial with a coefficient of x squared being 1. I'm going to split up my x squared. I need two numbers when multiplied together equal a positive 49, but when added together equal a positive 14. That's going to be a 7 and a 7. So I have an x plus a 7 times an x plus a 7 is equal to 0. By the zero products property, I can take the one factor and set it equal to 0. I'm subtracting 7 from both sides, and I get x is equal to negative 7. Now the other factor is exactly the same. So we don't need to do this twice, and we don't need to write negative 7 twice, because that's just one solution there. We only have one real number solution for this one, and that's negative 7. All right, number 5. Whenever we are factoring, we must set this equal to this equation equal to 0. So I'm going to add 12 to both sides. So I have a 2w squared minus an 11w plus a 12 is equal to 0. Now on this one, I have a quadratic trinomial, but my coefficient of w squared is greater than 1. So I need to use the x method. In the top of my x, I do my a times my c, so that's going to be a 24w squared. And in my bottom of my x, I'm going to do my b value, which is a negative 11w. I would need two numbers when multiplied together equal a 24w squared, but when added together equal a negative 11w. That's going to be a negative 3w and a negative 8w. Rewriting my quadratic equation, but instead of doing the negative 11w, I'm going to do the minus 3w minus 8w. Grouping my first two terms together and my last two terms, my greatest common factor out of my first two terms would be a w, and I'm left with a 2w minus a 3. I would need to factor out a minus 4 out of my next two terms to be left with a 2w minus 3. You know you did this correctly if both your parentheses match exactly. So one of my binomials is the stuff that's on the outside of parentheses, and my other binomial is this one set of our parentheses. All right, so now let's use the zero products property. The zero products property states that I can set this w minus 4 equal to 0 and solve for w this way by adding 4 to both sides. I would get w can be positive 4. And then I'm going to set my other factor equal to 0. So I have a 2w minus a 3 equal to 0. And I have a plus 3. I'm going to add 3 to both sides. So I get a 2w is equal to a 3. And then I'm going to divide by 2 on both sides to get w is equal to a 3 halves. So I get two real number solutions here. I get w can be 4 and w can be 3 halves. All right, in number 6, I'm going to start this off by setting my quadratic equation equal to 0 by subtracting 12 from both sides. I have a 2x squared plus a 10x minus a 12 is equal to 0. Now you are more than welcome to use the x method to solve this quadratic equation. However, there is an easier way. All right, for this, we have a greatest common factor. That greatest common factor is 2. And now when we were simplifying, when we were factoring polynomials, we needed to factor out that 2. But when we're dealing with quadratic equations, we can actually divide our entire equation by 2, and it doesn't change the value of your equation at all. Dividing or multiplying an entire equation by something doesn't change the value of the equation. So I need to divide every term by 2. So a 2x squared divided by 2 is an x squared, plus a 10x divided by 2 will be a 5x, minus a 12 divided by a 2 is going to be a 6, equals a 0 divided by 2 is 0. So now, instead of us doing the long x method, we actually can use the box method on this quadratic equation. I'm going to split my x squared up evenly. I need two numbers when multiplied together equal -6, but when added together equal +5. So that's going to be a 6 and a -1. So one of my binomials will be an x plus 6, and my other would be an x minus 1. And don't forget, this is a quadratic equation. We set it equal to 0. Now I use the zero products property. I'm going to take my x plus 6 and set it equal to 0 and solve for x here by subtracting 6 from both sides. And I get x could be -6. And then I'm going to take my second factor, which is this x minus 1. I'm going to set that equal to 0, and I'm going to add 1 to both sides to get that x could be a value of +1. So we get two answers, two real number answers here, -6 and 1. All right. Now, looking at number 7 and 8. If again, to solve a quadratic equation using factoring, we do need to set it equal to 0. So in number 8, I'm going to add 2x to both sides. And I'm doing this first because I want to show you guys something. Okay. Looking at my new equation for number 8 and my original equation in number 7, we should notice that both those equations do not have a constant. For example, in number 1, your constant was -14. In number 2, your constant was -20. In number 3, your constant was 18. In numbers 7 and 8, we do not have a constant. So we actually are going to do a different method of factoring, and it's actually going to be the greatest common factor method. In number 7, both my terms have a greatest common factor of 3x. And I would be left with an x minus 3. Now I'm going to use the zero product property. I'm going to set my first factor, which is 3x equal to 0, and solve for x by dividing by 3 on both sides. I get x is equal to 0. And then I'm going to set my second factor equal to 0. And by adding 3 to both sides, I get x could be a value of 3. So we have two real number solutions for this one. X could be equal to 0, but also 3. Same with number 8. We're going to factor out an x because that's my greatest common factor. I'm left with an x plus a 2. Setting the x equal to 0, I get x is 0. setting x plus 2 equal to 0, I get x is negative 2.